Building Decentralized Application Part 2. The Hardhat. We'll learn how to set up a Hardhat project, configure the Hardhat project, compile and deploy the contract. Let us create a new folder named Hardhat. Change into the directory. Next, we will initialize a node project using the command npm init. Go with the defaults. Type yes and enter. Next, we will install the Hardhat as a dev dependency. Next, we will initialize the Hardhat project using the command npx hardhat init. Choose the option to create an empty hardhat config.js. Next, open it in code editor. I'll use the visual code so I can open the folder in VS Code using the command code dot. Now, before we start, one reason to use VS Code is for its rich repository of extensions. These are some of the common extensions that I use in relation to decentralized application development. One is by Hardhat, Solidity, which provides language support for Solidity, including but not limited to syntax highlighting, IntelliSense, code formatting, etc. I also have a pretty code formatter extension for formatting for languages like JavaScript, React, etc. Before configuring the Hardhat project, let us install another dependency for the Hardhat project. So I can open a terminal in VS Code using Ctrl Tilt. Now let us install the dependency named Hardhat Toolbox using the following command. Now, Hardhat's Toolbox is a Hardhat plugin that bundles recommended packages and plugins to streamline Ethereum smart contract development, testing, and deployment. Next, open up the Hardhat config.js. First, we will need to import the dependency we just installed. We'll change the Solidity version to 0.8.20. Next, create a folder named contracts. Inside, create a file named cert.sol. Inside the file, paste in the certificate contract we developed earlier. Next, we will compile the contract using the command npx hardhat compile, which will compile the contracts and store the compilation output as JSON files known as artifacts. Next, run the Hardhat node. Next, go to the Hardhat configuration file. We'll modify it to connect to the Hardhat node we just launched. In the configuration file, we'll create a new section named Networks. Inside, we'll add an entry localhost with URL for the node we just ran, and an additional section Hardhat. This section represents a node environment with a default configuration and will be temporarily run when Hardhat deployment or test commands are run. So if it is a quick test, we don't need to run a separate node. For now, we'll make the localhost our default deployment environment. Now, we run a node because most of the time we want interoperability between various platforms such as Hardhat, Remix ID, MetaMask, etc. Also, running the node makes the environment persistent as long as the instance is not terminated. Next, create a new folder named Ignition. Within that, another folder named Modules, and within that, create a new file named cert.js. This is where we are going to write our deployment logic. Now, Hardhat Ignition is a declarative deployment system that simplifies Ethereum smart contract deployment by abstracting away the complexity of the process. First, we'll import the build module function from the Hardhat Ignition package. This is the core function for creating a deployment module. Next, we'll build the module, cert module, and export it for use in other parts of the project. Next, we will define a callback function. Within the callback function, we will define the module's deployment step. Now, M is a module builder object providing methods to interact with the contract. Next, we will instruct Ignition to deploy a contract named cert. Hardhat Ignition will look for this contract in the project's compiled contracts. Here, the module builder function creates a future object which represents the result of an execution step that Hardhat Ignition needs to run to deploy a contract instance or interacting with an existing one. For here, it is deploying the contract. Finally, we will return the future object representing the cert contract instance to make it accessible to other modules and tests. Next, we will open a new terminal and execute the following command. The Hardhat Ignition deploy command will execute every future we defined and show us the output. The deployment was successful and we returned the deployed address. We can also see the deployment in the Hardhat node log. Finally, if we look through the ignition folder, we can see some new folders has been created, specifically the deployments folder and a folder within that with the network chain ID. The first file we want to look at is in the artifact folder named sut-module hash sut.json, which has the deployed contract ABI and bytecode. This is the same as the artifacts we got when we compiled the contract. Outside, there is a file named deployed underscore address.json, which contains the deployed contract address. Both files can be used to retrieve ABI or the deployed address when we want to use them with the decentralized application.